Writing inverse equations. So for the past few days, we've been doing inverse equations and switching our x and y values from a table and then using that to help us graph. So the same idea applies to when you're writing the inverse equation. So step one, write the equation as y equals. So if I look at this first equation that we have function notation f of x equals 5x minus 15. So we're going to change that into a y equals equation. Step two, switch your x and y. So just like the table, you switch the x and y variables, the values that you have, you switch the variables here. So we get x equals 5y minus 15. So then the next step would be to solve for y. Remember, when you're solving the equation for the variable, you do PEMDAS backwards. So you want to get rid of things that are added or subtracted to your variable, then multiplied or divided. Then you would do exponents and parentheses, which we don't have any of those. And so that's next step. It'd be to add the 15. And then divide by 5. And for this, because this is a linear equation, remember y equals mx plus b. So we're going to write it in this notation. So that means I'm going to separate this, that 5 is being divided by the x and the 15. So this would become y equals 1/5 x plus, and remember that 15 divided by 5 is equal to 3. And then the last step 4 is to replace y with f inverse of x. So this is f inverse of x is equal to, and instead of writing 1/5 x, you could also write x over 5. That means the same thing, plus 3. So either way, that would be correct. So now let's go ahead and practice. So why don't you do the next two on your own. When you're finished, you can unpause the video and check your work. So for the first part, again, write this as y equals. Switch your x and y's. Solve for y. Divide by 6. And then write your equation. Y equals x over 6, or 1/6 x, minus 20 over 6. And for these values, 20 over 6 does reduce. Remember, 20 over 6 would be equal to 10 over 3, because 2 goes into both of them. So we're going to leave our number as an improper fraction here. So we can now write this as f inverse of x is equal to x over 6, or 1/6 x minus 10/3. Please do not write decimals as your answers. Always leave it in fraction form, reduced fraction form. Looking at question number 3, same thing. So y is equal to negative 1/2 x plus 13. So x equals negative 1/2 y plus 13 when we switch. Then we want to solve for y, so subtract the 13. And then the next step would be to get rid of the negative 1/2. So if you want to get rid of negative 1/2, recall that negative 1/2 times, let's do negative 2 over 1 would be equal to negative times negative is positive, and this would be equal to 2 over 2, which is equal to 1, which gets y by itself. So really, when we're getting rid of this, you can multiply by 2 and then divide by negative 1, but it's easier just to multiply by the reciprocal. So we're going to multiply by negative 2 over 1 on both sides, which is really just negative 2. So that means I need to multiply everything here by negative 2. So I want to distribute here. So I get negative 2x, and again, negative times a negative is a positive, so plus 2 times 13 gives me 26. And remember, this negative 2 over 1 times negative 1/2 is just 1, which means we have solved for y equals, and now I just need to write it in my inverse function notation. Looking at question 4, notice that this is not a linear function like the last ones that we did. This is quadratic. So same rules apply. So we have y equals 2x squared minus 11. Switch your x and y's, and PEMDAS backwards. So again, remember when you're doing PEMDAS backwards, we already got rid of the negative 11, which was subtraction, so we added it to the other side. Then you get rid of multiplication division, so what's being multiplied or divided by the variable was the 2, so divide by 2. And so we have 1/2 x plus 11/2 equals y squared. Then you do exponent in parentheses. So we don't have any parentheses here, but if we did, we'd do that last. So we want to get rid of that exponent. Again, how do you get rid of the exponent? You want to take the square root of both sides. And remember, when you're getting rid of an even power, you need that plus or minus in front of the square root. So in this case, we get y is equal to plus or minus the square root of 1/2 x plus 11/2. So here we have a problem because remember we learned last year that we don't like to have fractions underneath radicals, nor do we like to have, that means we just need to rationalize our denominator. So when doing that, it's a lot easier to work with this as one fraction rather than the two. So I'm going to rewrite it back as we had it before because it's not linear. So plus or minus the square root of x plus 11, excuse me, over 2. And now that I have that as one fraction, it's a lot easier to see how to rationalize the denominator, which we did last year. So just let's go back a minute. If I wanted to rationalize the denominator of something, so recall that if I just had the square root of x over 2, well, this is the same thing as the square root of x over the square root of 2. And again, we don't like radicals in the denominator, so that means in order to rationalize this, I'd have to multiply by root 2 over root 2. And why is that? Because that makes underneath the radical a group of two 2's so that we can get rid of that. And so this would be equal to multiply the numerator times numerator, the square root of 2x over multiply denominator times denominator, the square root of 2 times 2 is 4. And now we know that the square root of 4 is just 2, so this is equal to root 2x over 2. And again, you would not want to then divide those 2's because the 2 in the numerator is in the radical. And we did that in order to get rid of the radical in the denominator. So that would be my rationalization of the problem. So we can apply the same thing over here to our equation. So I want to figure out, because this is a square root, what makes this a group of 2, and it means I need one more 2. So I'm going to multiply this by the square root of 2 over the square root of 2. And when I do that, I multiply numerator times numerator. So x times the 2, that would give me the square root of 2 times x minus 11 over the square root of denominator times denominator, 4. And don't forget that plus or minus in front. So now we have y is equal to plus or minus the square root of, distribute, so 2x minus 22 over 2. And that rationalized our denominator. And then we can use our inverse notation. So f inverse of x is equal to plus or minus the square root of 2x minus 22 over 2. So now if we look at this, that plus and minus means we have two output answers. So this is a problem. Why is that a problem? Because remember, we're using function notation. And so function notation is saying that, this has to be a function if I use the plus or minus. But we know that if we were to look at our graph of our original equation, which is 2x squared plus 11, that's a parabola shape, which if I go to my calculator and graph that, we know that this does not pass the horizontal line test, so we know the inverse is not a function. And so if we go to our y equals, I already put in the inverse. Again, you can't put plus or minus in your calculator, so I had to put it into two different y equals y2 and y3. So with one just being positive and the other being the negative with the radical. And if I hit graph, now you can even visually see that the inverse is not a function because that doesn't pass the vertical line test. So what does that mean? That means that technically we should not use the inverse notation. And so we would just leave our answers with the y equals at this point. And later, we're going to talk about restricting the domain, but not right now. And so that will help us take care of the problem. So later, we will restrict the domain to find an inverse that is a function. And I should say restrict the domain for f of x to find the inverse that is the function. And so just be careful with that because again, we're solving something that's quadratic, which means you need plus or minus the square root. So technically we're not really supposed to use that inverse notation here because of that plus or minus means that for every input we have two output answers. So when this happens, we're just going to go ahead for now and just use our y equals, and then again, we'll later talk about restricting our domain. So looking at question number 5, let's go ahead and solve. So set it y equals, switch your x and your y's, subtract the 15, divide by 3. And again, this is not linear, so I'm going to leave this like this instead of splitting it up like we did for the linear function. So we have y equals the square root of x minus 15 over 3. Now again, we don't like to have fractions underneath radicals, which means I need to rationalize this. So I have 1 3 here, and to get rid of it, I means I need a group of 2 3's, because that takes it out of underneath the radical. So if I multiply this by root 3 over root 3, that should do it. And right here, when we take the square root, I forgot the plus or minus. I'm sorry, I just left out the step. This was y squared equals plus, or sorry, y squared equals x minus 15 over 3, and then we took the square root of both sides. I didn't write that step before. So that gave us this right here. So now if I rewrite this, we have the square root of 3 times x minus 15 over the square root of 3 times 3 is 9 in my denominator. Don't forget that plus or minus. So y is equal to plus or minus. And then you want to distribute in your numerator. So this is the square root of 3x minus 45, and the square root of 9 is 3. So that got rid of the radical in my denominator. And again, you do not want to redivide by the 3 there because that is underneath a radical and this denominator is not, which we did on purpose. So this right here would be our solution. And again, I'm not going to use that inverse notation because this is not a function because of that plus or minus. We have a sideways parabola. And again, we'll talk about restricting the domains later. So let's go ahead to the back side. So now we're going to work with, instead of linear and quadratic, we're looking at square root functions. So the same rules apply. We're going to first switch our x and our y after we set it equal to y. And so we get y equals the square root of 4x minus 8. Now we can go ahead and switch our x and our y's. And again, you're doing PEM DAS backwards. So we're solving for y. So I don't have anything on the outside of the radical being added or subtracted or multiplied or divided. I have stuff that's underneath. And remember, a radical is really like an exponent because if I have let's say the square root of a. Remember, that's really equal to a to the 1/2 power. So in this case, that radical is really like the exponent, and so we don't have anything on the outside being added or subtracted, but we do have this exponent that we need to get rid of. So how do I get rid of something that's a radical? Well, I need to square both sides. So we can go ahead and do that. And that makes sense because if you think about it, if you square both sides, this is really saying you have 1/2 times 2, and what's 1/2 times 2? It's equal to 1, so that would give us a if we were to do that. And so going back over here, we have x squared equals 4y minus 8. Now I can do what's in the parentheses, or in this case, what was underneath the radical. So now I want to go back and do PEMDAS again. So things added or subtracted, then multiplied or divided. So add the 8. And divide by 4. And so we get x squared plus 8 over 4. But remember, we have something that's quadratic, so y equals ax squared plus bx plus c. We're going to write it in that standard form, so I'm going to simplify this. So we have y is equal to 1/4 x squared, and 8 divided by 4 is 2, so plus 2. Now, can we write this using our function notation? So let's go ahead and look at this graph. So for the graph, I put it into my y equals and hit graph. Notice that this passes the vertical line test, so it is a function, and it passes the horizontal line test, so that means its inverse is a function. So this is a one-to-one function, which means we can go ahead and use our function inverse function notation. So f inverse of x is equal to 1/4 x squared plus 2. But we're not quite done yet, because this is a square root function, and this is a quadratic. And remember, something that's quadratic is a parabola shape. So if we go back to our graph and my y equals, and I graph my inverse and hit graph, notice it gives me this full parabola shape. But how can a full parabola be my inverse to this graph when I don't have a full sideways parabola from the original equation? Well, the answer is it can't be. So that means I need to restrict my domain values because, or write them out, because otherwise you're going to get this full parabola. So if we think about um, this being a reflection across the line y equals x, I'm going to just graph that. Notice that this part of the parabola here would be only this right side. So we actually have to think about the domain and the range for this function, because again, it's a radical, and we know that radicals can't have negatives underneath of them because those are imaginary solutions. So if I go back to my original equation, I need to figure out the domain and the range, and that's going to help me figure out my inverse. So the first thing I want to do is find my domain and range, and I can do that by right now just looking at the graph. So the domain of this looks like it is at 2, 0, so we can check second trace value. If I plug in 2, notice I get 0. And I'm going to talk about how to algebraically do this in just a second down below. So the domain is from parentheses, or excuse me, brackets 2 comma infinity, and the range is from, so we go back to our graph. Notice that when we plug in 2, the lowest y value is 0. So that means the range, here's your y values from 0 to infinity, including 0. And remember, for the inverse, it's switching your x and your y. So that means we're going to switch our domain and our range. So that means the new domain that we're using is for only x values from 0 to infinity. You can write the range if you want to, but it's not necessary, because if you're restricting your domain values, then your range has to be restricted. So this is the only thing we need to write. So we also need to include this as part of our answer. So this whole thing would be my solution. And again, you have to be very careful when you're working with the square roots to make sure that you include that in your solution set. So why don't you guys go ahead and do number 7 on your own and pause the video. When you're done, you can unpause it and we will check our work together. So first write this as a y equals. And then I'm going to switch the x and the y's. And again, PEMDAS backwards, so there's nothing added or subtracted on the outside of the radical. So we want to get rid of the square root because again, that's like the exponent. So that means we want to square both sides to get rid of it. And so that gives me x squared equals -1/4 y plus 5. And then now we're doing what's underneath the radical because that's like the parentheses. So we want to get rid of that 5 by subtracting it first. And then to get rid of the -1/4, we're going to multiply both sides by -4. That means we're multiplying all of this by -4. And don't forget you want to distribute, so we get -4x squared, negative times negative is positive, so plus 4 times 5 is 20, is y equals. The original graph passes the horizontal line test, which means the inverse is a function, so f inverse of x is equal to -4x squared plus 20, but again, we have a square root. Which means we need to find our domain and range to help us restrict our answer for our final inverse equation. So for this, we want to figure out where to restrict it. So let's go ahead and look at the graph. So here you can see your graph. So I know this value over here is at 20, and I can check second trace value 20, enter, and notice I get 20 and 0. And if you go to your table, if I scroll to 20, you'll see that that is where our graph starts, because then everything after that says error. So I know that's my lowest domain and range value. So if I go back here, then we can know the domain for this is from, and notice the graph is going the other direction, and that's because of transformations, which we'll talk about later. So notice that we're doing -infinity to 20 for our domain. And then the range is still bracket 0 to infinity because it's still going in the positive direction. So the lowest y value is 0, and it's going up towards positive infinity. And so that means for our inverse function, we have to use our range becomes our new domain for this function. So the domain would be bracket 0 to infinity parentheses. And so yes, you do need to write that because we can't have a full parabola answer since our graph is only half of the parabola with the square root. Now, if the equation instead had a plus or minus in front of the original answer, then you could use the entire equation because with the parabola, because then you're getting an entire sideways parabola, but then it's not a function. So for right now, we do need to restrict these. So the question is, how do I get that value without having to look at my graphing calculator? How do I figure out what my lowest domain value is to find my lowest range value? So keep in mind that we learned we can't have negatives underneath the radical. So everything that's underneath of here, if we just take that square root, we have -1/4 x plus 5. If I set it greater than or equal to 0 and solve. So first things first, we want to get rid of that square root. So how do I get rid of that square root? I square both sides. So what's 0 squared? Well, 0 squared is still 0. So this is negative 1/4 x plus 5 has to be greater than or equal to 0. Then we solve for x. So subtract the 5. We get negative 1/4 x is greater than or equal to negative 5. Then I have to get rid of the negative 1/4, so multiplying both sides by negative 4. And remember, when you multiply both sides of an inequality by a negative, that flips our inequality sign. So this becomes x, flip your inequality sign, is less than or equal to negative 5 times negative 4 is 20. So that actually gives me my domain, not from here, but again from my original equation, x values less than or equal to 20. So the domain is negative infinity to 20 bracket. And again, because that's what our graph looks like when we graphed it. So then how would you find the lowest range value? To find the lowest range value, you use your lowest domain and just plug it in. So if I were to do f of 20 into my equation, negative 1/4 times 20 is negative 5, and negative 5 plus 5 is 0, and the square root of 0 is 0, so this is equal to 0. That's how you find your range. So in this case, bracket 0 to infinity. And I know my graph goes up because the only way it would be going the other direction is if I had the negative in front of the radical. So again, that's how you would algebraically find it. So let's go ahead and look at those domain restrictions a little bit more. When you're finding the domain of a function given the equation, there are two red flags you want to look for. One is variables that make the denominator equal to 0. Why? Because we know we cannot divide by 0. And 2 is variables underneath an even root. Why? Because we can't have negative numbers underneath an even root. So for this, we're only going to focus right now on variables underneath even roots, and we'll talk about variables in the denominator in a later unit. So for the purposes here, let's go ahead and find the domain and range of each function. So for this one, when finding the domain for a radical function, you take what's the square root portion and you set it greater than or equal to 0 and solve. So the square root of x has to be greater than or equal to 0. How do I get rid of that square root? I square both sides. So when I square both sides, that gets rid of the radical, and 0 squared is still just 0. So x values have to be greater than or equal to 0. So that means the domain is going to be bracket 0 to infinity. And if it helps you to make a number line to see that, so here's 0, it's equal to, so it's a closed circle, and we want values that are greater than that, that goes to the right. So if it helps you to make that, that's fine. So the lowest range value you find by plugging this into your equation and solving. So if I were to do f of 0, I get the square root of 0, which is equal to 0. So that means that the range is also bracket 0 to infinity. So let's go ahead and look at the next one. So for the next one, same thing. The square root of x minus 1 has to be greater than or equal to 0. And then to get rid of that square root, we're going to square both sides. So x minus 1 has to be greater than or equal to 0. Add the 1. X is greater than or equal to 1. So that means the domain is values greater than or equal to 1. So bracket 1 to infinity. And then the range we find by plugging that lowest value in. So f of 1 equals the square root of 1 minus 1, which is 0. And the square root of 0 is 0. So the range would be 0 to infinity. So let's go ahead and look at number 3, same thing. So we're going to take what's underneath our square root, and you can just take that. You don't actually need to write the square root because you know every time when you square root, square a square root, it goes away, and then when you square 0, it's going to be just 0. So really you can just do 2x minus 3 is greater than or equal to 0. So then 2x has to be greater than or equal to 3 because we're going to add that to the other side. Divide by 2, so x is greater than or equal to 3 halves. We're going to leave that as an improper fraction in reduced form, which is already reduced. So the domain is going to be bracket 3 halves to infinity. And then the range you find by plugging that in. So f of 3 halves equals the square root of 2 times 3 halves minus 3. So 2 times 3 in the numerator, because this is really over 1, gives us 6 over 2, which is 3, and 3 minus 3 is 0, and the square root of that is 0. So the range would be brackets 0 to infinity. The range isn't always 0 to infinity, it just happens to be for these problems that we're doing that it is. So we'll look at one that's not in just a minute. So for this same thing, I'm going to go ahead and set what's underneath the radical greater than or equal to 0. So then we get divide by -2. That means we're flipping our inequality sign. So x is less than or equal to 0 divided by -2 is still just 0. So the domain for this one is going to be, again, if you make a number line to help you, here's 0. This is less than or equal to goes this way, so negative infinity to 0 bracket. And then the range, f of 0 is equal to the square root of -2 times 0, which is just 0. So this would be bracket 0 to infinity. And the next question you probably have is, well, how do I know that it's not negative infinity to 0 for the range? Well, recall when we talk about doing transformations. So what would make our graph, instead of opening this way, what would make it open down going this way? That would be a reflection across the x. So the only way I would get that is if there was a negative in front of the radical. If that was the case, then my graph would be opening downwards, and so then our range would be negative infinity to 0. But again, that negative would have to be in front of the radical, which we don't have right here. So let's go ahead and look at question 5. So this one's slightly different because we have a number on the outside. So the question is, what do I do with that? When you're finding the domain, remember, the only thing we're concerned about is variables that make underneath the radical negative, which we can't have. So we don't even need to worry about that too right now. But that's going to come in when we do our range. So for my domain, I still just take what's underneath the radical and set it greater than or equal to 0. So that means the domain is bracket 0 to infinity. And then the range, we do use that too. So f of 0 equals the square root of 0 plus 2, which is just 0 plus 2, which is 2. So there's no negative in front of the radical, so that means my range is going to be bracket 2 to infinity. And of course we can confirm this using our graphing calculator, but again, you need to be able to do this without your calculator. So root x plus 2, if I go to my graphing calculator, I can confirm the domain starts here at 0 to infinity, and the range is from 2 to infinity. And I can also check by looking at the table. And so you can see 0 and 2 are the lowest domain and range values that we have. And just to show you too, if I were to go back here and put the negative in front, when I have the negative in front of the radical, that's when my graph would be going the other way, and that's what would change it. So only when that negative's in front, then you have negative infinity to whatever the lowest range value is. And that's it for this lesson. So as you can see, writing the equations is a little bit more complicated than just graphing it or finding the table, which is why we saved this part for last. So just to recap, write the equation as y equals, switch the x and y, solve for y, and replace y with f inverse of x. The only problem we have is when we work with quadratics, we can do that if the inverse is not a function. We're just going to leave it as y equals, and we'll talk about restricting those domain values at a later date. And then coming to here, we had to be careful because when we're working with square root functions, we only have, if we don't have the plus or minus in front, half the parabola. So we need to find the domain and range to restrict our domain values for these inverse functions as well.